Hello, Professor. This is my presentation for topic 7, DQ2. Now I share my screen to explain my codes. For this assignment, the assumption of ANOVA are normality, which assumes that the residuals are normally distributed. For homogeneity of variances, the variances of the residuals should be approximately equal across all groups being compared. For independence of observation, requires that the observations should be independent of each other. The assumption of the linear model or linearity, where the relationship between the independent and dependent variables are assumed to be linear. For normality of residuals, the residual should be normally distributed. For homoscedasticity, the variances of the residuals should be constant across all levels of the independent variables. The limitation of ANOVA or categorical variables only meaning that ANOVA is designed for analyzing the differences among the groups, group means of a categorical independent variable. Each group size is another, equal group sizes is another limitation, meaning that ANOVA assumes equal group sizes. Unequal group sizes may affect the validity of the results. The sensitivity of outliers is a limitation, meaning ANOVA could be sensitive to outliers in the data, which might impact the overall analysis. The limitations for linear models are the assumption violation impact, meaning that if assumptions are violated, the results of linear models may be biased and the statistical inferences may not be reliable. The other limitation is overfitting, is that linear models can be prone to overfitting, especially when dealing with a large number of predictors. Non-linearity limitations occurs if the relationships between the variables not truly linear, and linear models may not accurately capture the underlying patterns. Now, what affects the validity is the validity of the results in ANOVA and linear models can be significantly affected if the underlying assumptions are not met. Generally, the assumption violations and limitations could lead to incorrect parameter estimates, inflated or deflated p-values, and unreliable confidence intervals. The overall generalization and applicability of the model's outcome to new data may be compromised, and it is crucial to carefully check assumptions, contemplate alternative models, or use robust methods when assumptions are not met to ensure the validity of statistical analysis. Here, what I have here is how the limitations be addressed or mitigated. Addressing or mitigating the limitations of ANOVA and linear models involve careful consideration of data characteristics, model assumption, and the specific context of the analysis. And how Python could be used. Here I have the code in the Jupyter notebook, shows the codes for the linear regression, and the data are generated with a linear relationship between the variables, which are height, weight, age, against scores. Now, this linear model summary provides the summary here. There's the summary of the results, provides information on how well the model fits the data and the coefficient of the independent variables. This model shows that a significant portion of the variance in the independent variable with all three independent variables contributed significantly to the prediction. And all the coefficients here have p-values less than 0.05, suggesting that they are statistically significant in predicting the scores. The visual here, this is the code for the visuals. The visual here shows this red line as the fitted regression line based on the linear model. It represents the predicted scores for different height against scores here. The ANOVA. To perform ANOVA with those values generated, a categorical variable was produced, and this categorical variable is called group. It was included to assess if there are any statistically significant differences in the mean scores across different groups A, B, and C. The results showed that the p-value here, the p-value is greater than alpha, while the result is not statistically significant at the 0.05 level, it is close. On the visual here, this is box plot. It uses Seaborn to visually represent the distribution of scores across the different groups, A, B, and C in the generated data. For this gives easy comparison, and it also shows if all outliers are present, and in this case, they're none present. So that is my presentation on this topic. So I stop sharing my screen, and thank you.